Hi, my name is Sofia Babanova. I'm a CTO and co-founder of Aquacycl, and we are here at Aquatech. Aquacycl was a sponsor at the Up Night last night, which was a great event to share our little failures that actually brought us to where we currently are. So what Aquacycl does, we provide wastewater treatment solution, on-site wastewater treatment solution for industrial customers with challenging wastewater. When I mean challenging wastewater, that means challenging in chemical composition or challenging within concentration range. Aquacycl technology is based on bioelectrochemical treatment process, which in reality is this little reactor in here. We use naturally existing bacteria to take the organics within the wastewater, convert these organics into direct electricity. So at the end of it, there is almost no biomass generation. We have electricity recovery and a significant reduction in greenhouse gas emissions. But we didn't come up with the idea overnight, right? There were little steps along the way. There were many lessons learned along the way. And if you come to our facility at San Diego, you're gonna see we have this beautiful wall of the history development of our reactor. And the whole journey started like 15 years ago when Oriana Brečko and myself, we were both researchers working within the area, playing with these glass reactors. But glass reactors, little glass bottles, cannot treat your wastewater. So we had to come up with engineering solutions how we can do that. And neither me or Oriana we are engineers. So our first solution was this pyro design, which the idea was brilliant at the time, right? We were thinking, oh, we're gonna take advantage of gravity flow. Water will go through this pyro and we're gonna treat the water and awesome. Never worked, right? Terrible engineering solution, didn't work out. Then from there, we were, okay, spiral design doesn't work. We cannot have our cathodes flexible. Let's move to something that is easier to manufacture. We came up with a rectangular design. We had this rectangular reactor, easy to set up together, but we had these huge openings on the side, so no even flow distribution. Terrible mass transport, didn't work out as well. So this one didn't go anywhere either. From there, okay, we're gonna change the design slightly. We're onto something like this, the size matters too. We have a good dimensions, but let's like have the openings on the inflow and outflow a little smaller to improve flow and so on. But the terrible idea behind that was that we used stainless steel reactor. Stainless steel bacteria and electricity generation and wastewater is awful. Who came up with that idea? Was it me? I don't know. But it wasn't a good decision. So we had a lot of corroding issues, abandoned the idea of stainless steel body, went to a plastic design. But we had this like huge ABS block when we had to carve the whole reactor out of it. The whole reactor body was very heavy, very expensive, although it worked out. So we knew that it works. From these like CNC machines reactor that was $2,500 each, totally unsellable. We moved to 3D printed reactors. We paid a company to make these big 3D printers for us. One 3D print takes 24 hours to do. You have to go in the middle of the night to change the spool. 50% failure, but the cost went down, right? We did our first pilot installations with this new reactor. Efficiency was there, but the money wasn't there. Like the efficiency of manufacturing wasn't there. So from there, we moved to our next version, which is this guy in here. Injection molded, rectangular, good opening, good water flow distribution, and so on. Still has minor problems. So from version 9, now we are moving to version 10, which will be released next year. So going along the way of this journey, right? It's like we were thinking every time there is something, we try it, learn something from it, and then it doesn't work. Of course, you should not be discouraged by the failures. You should be actually building up your knowledge based on failures. If we didn't fail multiple times, we wouldn't be here. We wouldn't be successful. We don't have this efficient system as it is currently. And we are gonna continue failing along the way. I'm pretty sure we'll have version 40 in 5 years. Who knows? So that was a little snap of Aquacycl history. If you wanna learn more, and if you're interested of what Aquacycl does, please visit our website at aquacycl.com.